just turned on my laptop so I could refer to some code on there, and I have a nice Windows boot up graphic with no other information, such as how to log in. So I'm going to try cold booting the machine and hope that I have, oh geez, it went into sleep mode or something. Come on, guys. Okay, well that didn't help. I have to. Okay. Now it's off. You think I have to click it? No, dude, I've used Windows for many years. Clicking and dragging the mouse up did not do anything in that case. It was messed up. It was fully messed up and not responding to input in any way. So we are now cold booting. All right, so now this is what it's supposed to do. Now we actually have the clock and all these things on there, right? So now if I click and drag the mouse up, it'll do it. It didn't have those things before because software is getting more and more broken. All right. Okay, so I'm going to the compiler source on my laptop because there's a lot of work that I did on here that is not yet checked in. Where is it? What file? Yeah. Go to that file. And then there was something that I don't actually want to copy. Wait, what? Oh, I reverted it. Okay, hold on. I'm in the wrong file. I'm in the wrong file. It's not in source copy, it's in source copy 2. Yeah. Okay. Great. Can you bother me with a lighter question about operating systems? Sure. Sure. Yeah, Windows, like the login screen on Windows is terrible now, and it's just like everything else on Windows. It's designed by people, quote, designed, unquote, by people who are bad interactivity designers, like, period. So I don't know what else to say about it. You've been thinking lately what base features an OS should have, and what should be software that users choose to install. I don't care. I don't give a crap. Like that's not the OS. Like what you're talking about is not the OS to begin with. Like the OS is the thing that determines how software works on the computer. Anything that's actual application software is not the OS. I mean, if you're being non-colloquial about it. Like there's just way too much. You know, you install an Ubuntu machine and there's 4,500 executables on there. I don't want 4,500 executables on my machine. But on the other hand, the problem isn't that they install everything. The problem is, why is there that much stuff to do so little? That's the problem. It's not like, it's like asking how much of the software should people get by default is the wrong question. The good question is, why do we have so much software just to run a computer and let you like open files and stuff? That's the question people need to be asking. If you could cut that down by a large degree, then maybe it's fine if you just distribute it to everyone by default, because it's not a giant pile anymore. Lenovo recommends that I install these updates. Yeah, great. Please don't ever recommend Linux distributions to me. It's the number one thing that annoys me. Do not do that on this channel. Thank you. My impression about hardware design like CPUs is it is also more complicated than it should be, but not anywhere near to the degree that software is. That's my impression. Yesterday I said I may hire an intern for the summer. No, I didn't say that. No, I didn't say that. I jokingly said time to hire a summer intern. Cut as much as possible, but at some point you start to think a lot of beginner users would prefer a minimum level of base features. But you're not listening to what I'm talking about. I'm not saying cut features. Linux doesn't have that many features. The audio doesn't even work half the time, right? Like logging in doesn't work half the time. Okay? Linux does not have that many features. It's got a tremendous amount of software to provide not that many features. That is the problem, okay? The amount of software per feature is very large. That's the problem. You shouldn't have to cut features in order to cut down the amount of software you're distributing. It's way too much. Dude, systemd is like over 1 million lines, and that's just to let you boot your computer. Like, what's going on? There's no adult supervision anymore. Isn't Linux mostly driver code? I just said there are 4,500 executables installed by default. God, this discussion is already going to make me very angry, so I'm going to stop engaging in it. I'm just going to stop engaging. That's on Ubuntu. every Linux distribution is almost as bad. God damn it, dude. I'm just going to hit the stop button if this keeps going. I'm sorry. I'm already a little bit annoyed, and people are just being annoying. All right, let me at least try to get a little bit of work before I get too frustrated and hang up. Let me find the thing that I was doing on the laptop. Aha, yes. So let me actually update the compiler, get recent changes. We did do that, I guess. That's exactly right. Oh, just try this distro. This is totally the good Linux distro, not like every other Linux distro. Okay. Yeah, for some reason, the tenor of chat is very different from what it's been the past few streams. We had good chat last stream and the stream before. It's true. It's true. Put on your good chat hat. Put on your good chat hats. Do I think accredited colleges should be shamed, called out for offering developer boot camps? I don't think calling out or shaming is appropriate in any way right now. It's like, that's the number one thing that makes me not want to talk to someone ever is when they engage in that activity. Because we've just got too much of it today. That said, I think accredited colleges are mostly a scam right now. So like, what's one more piece of scam? I don't see the problem. Like what people are paying for is not education. They're paying to have a certificate to say that they have a certificate. So, you know, that's the value of those institutions right now. Do I think game studios should incorporate significant research-only departments into their structure, like general tech companies, or is the tech industry already too risky and competitive? So the thing is, if you're talking about a game developer, the size to make one individual game, those companies are much, much smaller than companies like Microsoft or Google or something that actually have research divisions. And it's not exactly practical at that smaller size. I mean, it's harder. I don't know. I understand why it isn't done. Put it that way. Do I force the standard 8-hour workday? No, we don't care when people work. All right. So, oh, I hadn't even done that. Okay. So what I'm going to do now, we have this polymorph solver that, figures out what the types are of things when you're calling a function that's polymorphic or using a struct that's polymorphic. And in the current build of the compiler, there are occasions when it does something a little bit unstable, right? That I wanted to debug. But then I was doing a very large, scary restructuring on my laptop actually a month ago. And then the laptop died and I had to transfer the drive to a new one. And I got it to the point where that restructuring was basically done. But it had a problem where I couldn't check it in because the polymorph system was going crazy in a way that was not good. And where if I fix it the right way, it should actually improve performance of the compiler overall. So I want to do that separately. I want to restructure this the way that I want it on the current compiler. And then if I plug in the rest of my update from a month ago, hopefully it'll work all the way, right? And so that's the plan. And I can sort of explain while I'm doing it what it is. I just want to, yeah. This is going to be a little bit annoying to copy it all over, but that's what you got to do sometimes, right? I can't copy the whole source tree over because that'll just introduce many randomizing elements. I want to do this on a version of the source that is currently working and make just this change in isolation, right? Like sometimes you make a big change and you realize, oh, this would have been easier if I'd done this other thing or that other thing first. But now I'm doing these three things at the same time, and that's really scary. And if you were able to roll back and just do the other one or two things first in isolation on the old version of the code before you tried to throw the switch on everything, that could sometimes work out better. So that's what we're doing. Okay, so we're doing this. So the problem is the following. When we call to do a polymorph, that could cause an arbitrary amount of more computation to happen in the sense that, you might need a type to be finished. Well, let's just explain it this way. When you get called to do a polymorph, you don't know if you actually could successfully do it yet. Because you might start solving for the types, and you might end up saying, oh, we need to know what like hash table of string comma float is, right? And then actually resolving that type of hash table of string comma float so that you can use it may involve doing some compile time execution, for example, right? And then compile time execution has to go, and then you have to come back later. So what we have been doing in all versions of the compiler up until now is giving up and returning when that happens and trying again later. And the thing that was making the compiler go a little bit crazy is sometimes it gets confused when things like this give up and try again later. If you don't tell the compiler that that happened accurately, then it can think it's still making progress, right? When really like you have an undeclared identifier or something, it can think it's still making progress and then infinite loop, right? And so one way to fix it would be, well, just make sure the compiler knows that we rolled back all this stuff and didn't do it. But that is easier said than done sometimes. And it's just bad in principle that this thing has to give up and try again, because it could be throwing away a large amount of work every time it gives up. And so if we want the compiler to stay fast as code gets more and more complex, we want to go in and like fix issues like this one. Okay. So I'm just going to start typing in again what I did. So basically we need to make a state record that talks about where in progress the polymorph is. And then we pass that every time, and then anyone who does a polymorph needs to remember that state, right? So that when it comes to retry it, it'll retry it, but it'll retry it given the current progress and continue forward, right? And so let's do this. So solver. Okay, so this is like at one of the first things we have to do is decide which of these are we going to do. Are we looping or non-looping, right? Or do we need to decide? So this is going to be set to 0 when we first go into polymorph. We're going to do some computation to figure out which one of these, and then we don't have to do that computation again, right? Because we record the thing. All right, but the main struct is going to be this. Solver state match solver mode equals solver unset and lambda source lambda. This is the thing that's polymorphic that we want to turn into something else. Why can I not type my... I keep hoping my typing will improve to where this double capital letter thing doesn't happen, but it never... Oh, I blame modern keyboards. Okay, so that's our struct there so far. We might need to add more things to it because I don't remember where I was in doing this work. Okay, so we can actually do this in pieces. Okay, so we can go to solve for matches. Solve for matches is the main function that gets called, right? And then it decides, do we need looping or not? That was this thing here that we're talking about. By the time we get down to here, looping is true or false. And I had this function solve for matches non-looping, but solve for matches looping was just the rest of the body of this function. But I'm actually going to factor it out because it's long and complicated. So this is a thing we can do, is just make a solve for matches looping, and yeah. Like that. And then this function will be short and etc. And we're not going to need to have as many parameters eventually, because a lot of these parameters are going to live on the polymorph state struct that we just did. But we're not going to do, we're doing this one piece at a time. So we're saying solve for matches looping. All right. And that is going to have all this. Look at all that. Bam. Okay. We may need more things. Let's just see what happens when we try to build this. Oh, it's C++, so you can't just do that. You can't just make a procedure and call it. That is not allowed. That is UB in C++ to just make a procedure and expect to be able to call it. You have to also do the other thing. Okay. Inputs you cannot assign to a variable that is const. Well, that's great. So we're not changing the size of the array. Let's see what we do to inputs here. I think I can just make it non-const. Like, again, we're going to move it onto the struct later, so it won't be a big deal. I just want to be able to do an incremental thing. Yeah, I think we can make it non-const. Of course, this is C++, so you can't just make it non-const here. You also have to go back here. Oh, whoops. I actually could make it not be a reference, but we'll make it be a reference for now. Okay. Come on. Oh, I changed the wrong one, guys. I changed this one in all the word salad and not this one. All right. Looping undeclared identifier. Hey, that's great. Well, yeah, that we don't care about. All right. Hey, we got it. Okay, so at this point, we should in principle be okay and still be able to compile the game. How has working in the new language changed the way that you write C++? I just don't care anymore about C++, so I'm much more sloppy because I'm just getting off the language. Like, I used to try to deal with C++ weirdnesses as best as possible in order to keep my code quality high, but I don't care anymore because I can't deal with it anymore. So apparently we have a typing mistake in the enum values. That's great. Thank you. Fortunately, we haven't tried to use these yet, but it's always good to catch the problem before it happens. Okay. Yeah, that happened because I copied and pasted this line and just deleted non, and I just didn't change the number. That's a thing that I do. Okay. So we should be able to build the game and run the tests. And I kind of just want to, because this is a very precarious change that we're going to do, I kind of just want to check this in. All right, so we can run the game and let's run the tests. All right. Great. commit. Uh-oh, we have some math stuff that I didn't commit this morning. Let's put those in separate check-ins. Math lib tweaks. Bam. Oh, come on. I've got a no check-in in there. I don't even want to work on that right now. Oh, it's just this. We're fine. Great. Okay. And then start of polymorph overhaul. 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 Okay. Great. Now we want to start using this state thingamabobber. So I had gotten some ways into doing this before. And I'm just going to transcribe what I did. But I never got it to the point where it was working. So we're going to see what happens. Okay. So what we did was we just passed polymorph state, right, as all these variables. All these things go away, which is nice, because we don't really want that many arguments. I'm just going to put these here for a minute so I remember what they were. And here we decide if we are looping or not, right? So now we might either come into this function if we're polymorphing for the first time, in which case this will be a blank match solver state that's constructed to the default values for everything, right? Or it'll be a reentry, in which case we want to skip the earlier computation. So here we're figuring out, should this be a looping polymorph solve or not? We do it by saying, is the thing that we're matching against also polymorphic? Like if only one of the, if only like, for example, the function that we're calling is polymorphic, but all the arguments that we are giving are not, that is considered a simple case and can be solved in a more straightforward fashion, right? So we need to figure that out in this pre-pass, right? And so what we're going to do is use this match solver mode, right? It starts as solver unset. Max. Oh, there we go. I'm just trying to. Why doesn't this work? There we go. God, how bad can you make your software, guys? I should actually, because half and half is a little too narrow, I should actually make a mode that's like this by default, you know, just like 1/3, 2/3, or 2/5, 3/5, or whatever this is. I feel like that makes a lot of sense. Okay. Anyway, so what we want to say is if state mode is solver unset, right, then we have to do all this stuff. So, well, we'll keep our looping variable there, right? And we do all this stuff. And inputs is now going to be on state as well. That's not going to be, right? We removed that from being an argument. That's now here. So we're saying state inputs, right? And actually, we can do this in a rippled, okay, watch what we're going to do. This is going to be fine. We're going to say, look, if it's solver unset, right? And then we say if looping state mode is solver looping, else it's non-looping, all right? So once we've set this, now if we call this function back with the same state pointer, we will never do this again. We'll only do it on the initial call. And that is the whole trick of what we're going to be doing. We're just doing that over and over and over to different pieces of functionality. Okay, so there we go. And now we come down to here, and this looping variable doesn't exist because it was local to here. So we're going to say, if it's looping, we'll do this, right? For some reason, I like it better this way. Okay, now I want to be able to do this incrementally and have stuff still work. So a little bit of a headache is the callers of this function have to set all this up, right? Because they need to pass a different argument. So let's do that. Let's actually do the argument setup and this part, and then we'll leave these guys as they are, and we'll maintain a working program and check it in, right? And then if we screw something up really bad, we can always roll back to the check-in. And that is the thing that I can do right now that I couldn't have done. Remember when I was explaining 20 minutes ago that, you know, I was in the middle of huge changes to a bunch of other things, so the compiler wasn't working at all. And then I realized I had to rewrite this. And then it's like, oh my God, if you don't have a working thing to base off of, it's really annoying because you can't notice when you suddenly added something wrong. But here we can just roll forward, change by change, and make sure things stay working. It's a much easier way to program. All right, so here we're going to do really stupid stuff here. We're just going to go state arrow this, state arrow this. What do we do for solutions? Ampersand state solutions, I guess. What was solutions return? Yeah, that was that. So it wants a pointer to a match status. So that's a match status. And then vargs element index. Where are we? I went too far. So that's on state. And then the rest of these things are normal things that don't change. Whoops. So then we just do this to both of the calls. Okay, so now the problem is first we're in C++, so we can't just change the function. Right, we have to go to here and do this. You have to do everything twice at least in C++. All right, so we did that. Now, everybody who calls solve for matches needs to be fixed. But one of the superpowers of using a strongly typed programming language like this is you don't have to search for those. The compiler will tell you where they are. It may also tell me some other things that I messed up, but it'll at least tell me where the callers are. Undeclared identifier match solver state. Okay. I could just do this. You know, we're going to do this a few times, so we'll put it up here. This is just a way in C++ of saying, look, trust me, it's in C actually. Trust me, there's a struct called that. We're just not going to tell you what it is right now. But this is totally a thing, man. All right, so we're still using this old parameter underscore inputs, which, yeah, we don't need that. Is polymorphic overload doesn't take, oh, that's just a broken error message. All right, so we have more inputs, right? I missed this and that. Okay, so now we have someone trying to call solve for matches. Function does not take 7 arguments. Okay, now this is interesting. see how see this thing that's happening here, this progress arrow step is equal to what? That is the same thing that we're doing in this other area. But I did this thing called polymorph prep progress before. So we're just, it's the same structure. Same structure. Are there any questions about this? I'm getting cold and I want to make some hot tea. So, any questions? I need to save the chat from talking about useless Linux things. What is an animal that like eats penguins? Like a snow leopard or something? That's already taken. Otherwise my my operating system's mascot would be a snow leopard. Polar bear? Polar bear. Seals? Seals are kind of nasty though, dude. Orca? That could be good. Is there anything that needs to be drastically changed in art for game development? Epic thing that loads in different LED without baking seem neat, but I don't understand how it works. Well, do you mean technical things? Do you mean tools for game development, art creation, or what? I'm not quite sure I understand the question. Bird with human teeth. How about a brick? No, because if I make it the mascot a brick, then Antifa will try to use my operating system, and I don't really like them. So, tool or techniques for art creation. Well, yeah, I mean, there's a great deal of progress that can be made in that area. We should continue to work on it. What exactly should that look like? I don't know. Like, part of the work that needs to be done is just figuring out what is cool ways to make game art, you know? Where did I learn to program? In the 5th grade on a Commodore VIC-20 computer. No troll. No, I'm sorry, I lied. It was the 6th grade on a Commodore VIC-20 computer. 6th grade. All right. Polymorph solve for matches does not take 7 arguments. So we need to bundle this stuff up. And for now we can just make the dummy struct, pass it in. It's like, yes, we want to save it, but for now we just want to keep the code working. And we're not trying to go all the way in one step. So we can go here and we can say, what is our thing called? Match solver state state. So actually I lied, right? Like what's going to happen is we are going to fill this out every time. So I said before, well, what I said before was, look, if we ever call this with the same pointer, it won't do the work. Well, we're going to change it every time. So it will do the work. But yeah. So we're going to say state arrow source lambda. We're just going to put the arguments in here. State inputs is progress inputs state arrow oh wait, the polymorph progress has the solutions on it. We'll just change that then. And some of this is redundant. So we might just want to put this on the polymorph project or progress. Or we might just want to put a pointer to the polymorph progress onto this thing. Peter Piper picked a peck of pickled peppers. And this is not arrow, this is dot. Whoops. That, okay. Okay, so then we're going to change all these arguments and go ampersand state. All right. Have I checked out Desperados 3? No. Why would I? Yeah, chat, I'm regretting reading chat right now. Okay. We're just making this work. This might not be the only call to solve for matches. I'm just going to say colon polymorph there. I don't want to say no check-in because we want to check it in an intermediate way. 1310. Oh yeah. We wanted to change that to arrow solutions, which means this is not ampersand anymore. Varg's element index, not argument index. Apparently, I made the wrong name. Okay. Okay, I'm going to make that tag be called polymorph state. All right. That is what it is called. And I guess that's the only entry point, which means this could be a substruct of the polymorph progress struct. which is honestly quite fine. Like maybe this match solver state, just all these elements go on progress. What's progress? Let's look at what that is. Polymorph prep progress. Peter Piper prepped a pickled poly prep a. Okay. So we have polymorph prep, polymorph do. I feel like this is supposed to be, this was supposed to be what, oh, polymorph do is like making the lambda? Let's see. We could just call this one polymorph match progress and put it on there. Yeah, so polymorph do is like when you're actually making the lambda, which itself you might not be able to straight up do. All right, this all makes sense. Okay, yeah, we're going to juggle some things around. But not yet, because we want to have a working compiler first. We want to verify that. That's the whole point. We are building the release build. So that worked. And this is our game compiled with our brand new, spankin' fresh, slightly refactored polymorph prep. And if you can just keep doing this all day, you'll succeed in the game industry. Also, though, if you oversteep your tea, you will not succeed in the game industry. So I might have just done that. I might have. It's not too bad. It's a little much, but it's not too bad. Okay, you know what? We check this in. We say polymorph overhaul step 2. Okay, so now we're going to take this match status thing that we made, and we're actually going to put it together with all this other stuff. So match solver mode and match solver state. Okay, that's going to be over here. We'll make that a U8 because we seem to be doing that. This is going to be called polymorph match progress. That's all. And then we're even going to keep these redundant elements on it for a minute. And we're going to put that here. Let's just call it match progress. Oh, no. Whatever. C++ is annoying. Okay. So this is good. So now we have to change some things. Again, because you're in C++, you just can't leave well enough alone. Wait, match solver state. This is actually match progress. Right? And then we replace, whoops. No, that was bad. Polymorph, match solver state with, I actually kind of like the word match solver state better. And then instead of state here, we're going to say auto state is ampersand progress arrow polymorph match progress. All right. And then now we're no longer creating it on the stack every time we call. So now we actually maybe run the risk of something weird starting to happen if, well, yeah, okay. Okay, so I kind of want to move this, the solutions and the element index. I feel like maybe they don't want to live here. Maybe they do want to live here. But I don't want to have to copy them here, so we'll see. And we'll call this I don't know. All right. Suddenly 1 million lines per second. That's not going to happen. But, well, it won't happen today, not suddenly. Okay. Oh, because we're taking the address of it here, which we don't need to do anymore. Okay. What's going to happen? All right. It seems to be working. We'll hit the button a few times. What is the speed of the compiler? It's about the same. It's actually a little faster. It looks a little bit slower when I hit this. It says 1.3 seconds, but that's because we've got all these frickin' WWise libraries. So we're spending more time in the linker, which is not our fault, but that we can't do anything about yet. But we will eventually, hopefully. We're spending half a second in the linker. So it's a little over 0.8 seconds in the compiler and then half a second in the linker. So, and meanwhile, the actual Sokoban game has continued to get bigger, right? So we're doing 90 to 140,000 in 0.8 seconds in our code, right? It's 0.68 in the front end and then 0.12 in the back end, right? So it's 0.81 something. I should actually reformat this to be like, here's how much time is our fault. Here's how much is the linker that we can't do anything about right now, right? Because the front end, back end is a little bit weird. Is that for 100K lines of source? Yeah, 140,000, including blank lines. And like this tells you how much source, right? So 92,000 that have code on them of some kind, or 140, including blank lines and comments. Why do you still need the linker at this time? So the problem is with this game, and for many people who may want to use this language, you still want to link against some libraries that are programmed in C or C++ or some other language. So you still need a link step. Now, even if you don't do that, even if you're totally native, right now we still have to have a link step because our compiler doesn't know how to generate an executable directly, but we can fix that part. That can happen. The thing that I don't know what we can do about is the actual link step on the operating system. Linkers are terrible. And yeah. So we'll do what we can do. If we can figure out something to do with linking to help, then we may, but who knows? Like one thing we could do is like notice if you keep linking against the same sequence of libraries and do like a pre-link of all these libraries together, which may not be that much faster, but then you could link against the cached pre-link thing. It's just I hate that kind of stuff because that starts to go wrong and Have I ever profiled LLD? No. In game development, 99% of the time you will link against some external stuff. Steamlib, epiclib, or whatever. That is true. You almost always are going to be linking against something. At least in the foreseeable future. In the far future, if this language is successful, then maybe people just prefer source libraries enough that we don't have that. Or, right, so if something's a dynamic library, you don't necessarily have to link to it in order to use it, right? You can load it at runtime, and we can actually make that very easy, and then you wouldn't have to have a link step for that. Or if you wanted to put it in at compile time, we could probably do that pretty easily if we make an executable. It's just linking against a static library that is more annoying. What was the original estimate? Well, there wasn't an original estimate, but the goal right now is 1 million lines per second. I think I might have said at one point 200,000, but the goal is now eventually 1 million. And we might be at 200,000 right now. So if you take this and divide it by 0.8, right? We're at 175 if you count blank lines and comments, right? So, that's all right, but it can be a lot better. It can be tremendously better. Can we make DLLs now? Yes, but I think we use the linker to do that as well. I think we write a .o and then tell the linker to make it a DLL or something, which is something I would like to avoid as well in the future. Okay. What is happening? Well, what is happening is that things appear to work, right? So that's a good place to be. I feel like we haven't done that much. So let's try to get these parameters into the right place. Let's look at progress arrow solutions and see what is going on. Okay. So I don't think that we do anything on that to set it up. So I think we could move it. Yeah. Let's try moving it. So we're not going to do this. We're going to take the solutions. I don't know if it's worth breaking into this many structs. I don't know. Okay, so we're just going to put this here. We're going to take it off there. All right. Oops, let's delete this whole thing. We're going to ampersand that now. Getting hungry again. Let's see what complains. Solutions. 4545. In the year 4545. Why are we reset? That's scary. Oh, this is just error reporting. All right. This is still scary, but it's not as scary. All right. So I think that's it, and I think we can do the same with that varargs index, maybe. Quality. So let's look at okay, wait. So that's a local, that's a local, that's a local, that's a local. That's, oh yeah, okay. In Typer, we don't use it. So here, we get the index, and then we copy it. That's it. That's literally it. Okay. So let's call it argument index. That's going to give us a little. I just want to be consistent on naming. All right. And then this inputs array, actually, we might want to move that. Let's just get this done first. All right. Okay, so let's talk about inputs. Okay, that's on match progress, which is where we want it, I think. So we just add it there, we copy it there, and that's it. So, whoa, what just happened? All right. Okay, so we're going to do that. We're not going to do that. And then someone is obviously using this on the way out. I don't know if this is the right place for all these things. What? Literally nobody looks at that. All right, great. So it's only used very locally there. Okay. This is bothering me right here. I think it's time for another incremental check-in. That feels to me like the thing. Did I just do this? I'm spacing out, guys. We're going to do it again because I don't know if we just did it. Well, we didn't run the game. I know that. All right. I think we did just do this, but we're going to do it again. This is good. So no matter what, all right, no matter what happens, we have a little bit of a win in that we're already further along in doing this restructuring that I know needs to happen, and we still have a working compiler. That is good. Some people take a week to do as much work as we have just done in this 1 hour. A lot of people don't even do that much. So we're doing good. Even on days, like I was feeling a little tired today. I'm like, But, you know, even on your slightly tired days, you just keep pushing forward and you make things happen. All right. Or you take a day off. That's okay too. Can I give some examples of useful applications for calculus and differential equations in games? You were told you should learn these, but never bothered. They are less prominent than linear algebra for sure, but you definitely use them. I would say you use calculus, you use integral calculus, or what would you call it? Like, you know, if you have an equation with a derivative that's like not recursive, that's not considered a differential equation, right? Or whatever. Whatever the official definition is of differential equation, but the simpler kind. So just like, you know, an equation with a derivative that you have to integrate, or you take the derivative of something, like that kind of thing, you do use a fair amount in games. Like for graphics, or like even in Braid, a 2D platformer game, I had a thing where I had to take I had to figure out, what's the equation in the limit as something approaches infinity of blah, blah, blah. Like I had to do that. So you do use it. But what I would recommend is if you're not totally hyped to preemptively learn that stuff, that's okay. You don't have to. But look at it enough to know what it kind of looks like so that someday if you ever run into a problem that will actually use that maybe, or for which that would be relevant, then you're a little bit prepared, or you at least can recognize, oh, maybe that's a tool that I could bring to this problem. And then when you want to go solve the problem, you'll be motivated to learn the thing maybe, right? Because now you know what you want to use it for. And the fact that you want to use it gives you more of a focus, right? Instead of like, oh, I have to learn all of calculus or whatever. It's more like, oh, I need to know how this one thing works so I can make that apply in a certain way to this problem that I'm trying to solve. It gives you a much more constrained and defined problem. And that's very useful, I think, sometimes. Vector calculus is basically required for games. I wouldn't say that. Scalar calculus is important. Vector calculus, we honestly don't use that much. Again, maybe a little bit in shaders, but like, Like my vector calculus is very shaky. I basically don't know any vector calculus, honestly. I mean, linear algebra, I think, is... so there are, math, all these different subfields of math connect to each other, right? And so the part of vector calculus that I understand very, very clearly is the part that corresponds to just static linear algebra and shapes and stuff, which is like, okay, I know what the tangent plane to a manifold in 3D looks like, right? And I know how that behaves as you maybe move it around the surface and whatnot. Like I know how it has a local coordinate system and you can transform into that. But none of that is calculus. Those are just ideas that get used in calculus. But in calculus, you're usually like, there's some kind of integration or differentiation involved. That's why it's calculus, right? So I do not know a lot of that stuff. What is used for physics simulation? You probably, if you were writing a physics simulator, you probably would use a fair amount of differential equations and or scalar calculus. Although I haven't done that, so it's hard for me to say. How would I explain what I'm doing to someone who doesn't know anything about programming? I probably wouldn't. Like, if my priority was to teach the person, I would sit down with them and do something simple. Otherwise, I would just let them try to follow along the best they can. If you were transported back to 1789, could you build a useful computer? That's a very specific year. I mean, okay, so you can build simple logic gates out of wood, for example, if you wanted to. So you could start with something like a replacement for an abacus, right? Like a digital abacus. You probably would want to make it out of metal, honestly, but you know, you could start with wood if you want. Um, and the question is, right, you would need to gather enough resources to go for bigger and bigger things. So you would need to find some people who could use something like that, right? Anyway, I don't know. Like, I'm sure that they had, in like 1789 is pretty recent, all right? Like they had things better than abacuses already in 1789. So you would have to figure out what you could do. Didn't some old timer use a weaving machine? Yeah, the jacquard loom is sort of the predecessor to a lot of things. So you could, for example, say like, look, I know that the jacquard loom was used to do textiles, and that probably already existed in 1789, right? I'm not sure, maybe not, but you could at least invent that and or then start using that for computation, right? Jacquard loom is 1801. So you could be 12 years early if you went back to 1789. Oh wait, was it 1879? Wait, now we're, oh no, 1789. Do I think a game should only be in 3D if it's warranted by the gameplay? It's hard to say. There are other reasons, like doing a 2D game with a lot of bitmaps is just really hard in some ways. Like if you want guys to move around and whatever, like drawing bitmaps for that is hard. So you're either going super lo-fi or 3D hi-fi, I think. Or you could do a 2D skeletal animation system. How does a new programmer figure out what area to specialize in? Well, I mean, what are you interested in, right? Just do what you're interested in and you'll learn more about that area and you'll see what is relevant to you, right? If you don't know yet what you're interested in, that happens sometimes. And then I don't know, you just gotta try a lot of stuff, see what sticks. You were imagining going to the home of Edison and inventing a massive Edison light bulb array and making the world's first 3D game. I would start with 2D, but you totally, like, you could make Pong in the 1700s with light bulbs. Or no, light bulbs didn't exist. Wait, when were... They didn't exist then. I'm so tired right now. 1879, right. I was mixing up my 1789 and 1879 again. 1879 was a big year, honestly. I bet you could make Pong in the 1780s. You just would have to figure out, like the display would be like, you'd have to be near a river, right? So that you have like a water wheel driving the thing. And then the display would be like, the pixels would be shutters letting light in through a window or not. So you can't play at night. They'd get jammed a lot, but you probably could do it. It would be a challenge to make it run fast enough. You could put it in front of the fireplace. It wouldn't be that small. I think you could invent all this stuff except a big enough generator for enough power. So, you know, the thing that I've thought about a lot is the thing that you could invent is refrigeration, like modern refrigeration, which, as I understand, I always look up how this works and then I forget like a month later. But the whole like adiabatic heating thing where like you heat one end of a pipe and it somehow makes the other end colder, that's like magical. And you could have done that a long time ago and people didn't figure it out. Right? I'm looking on the Wikipedia page. So it says 1834 was the first refrigerator, but dude, if you could make that work with a lead pipe, like lead was not the best metal, but they had lead pipes in Rome, dude. People did figure out evaporative cooling. That is true, but this is a different thing. This is like you can turn fire into ice, which is crazy, but that's how your refrigerator works, right? Tell them meat does not turn into... Oh, that's the other thing you could invent is the lens. Like, people knew that glass distorts light for as long as there's been glass, right? But like the fact that you could shape it very deliberately and make a magnification and see things that are small or large or far away, or, you know, large and far away, I mean, right? That could have happened way earlier in history than it did. Like, again, we've had glass makers since the ancient world, but let's see. When was the telescope invented? 1608. All right. But they had glass jewelry and stuff in Rome again, in ancient Rome. So like all you had to do was start polishing that glass down to the right shape and like put it in a tube and you win. So what easy invention will people 100 years from now going to talk about that we 2020 monkeys couldn't figure out? That is the magic question. And that is always the case. We are missing basic stuff that we just didn't think about or wouldn't know how to do, or we're too busy arguing about Chaz to like actually do any work. And a time traveler back to this time could do all kinds of things. Like I think way more than in previous centuries, because we have way more technology now. Like, there's all kinds of holes in what we're doing with it. So yeah, there is plenty that people could do. You thought we had lenses for thousands of years? Well, so I think that what we had, and again, I'm not super educated on this, but there was definitely a thing, like people knew that spheres of glass had interesting optical qualities. And if you cut one in half, it acted like a magnifying glass, right? And so there were like, priests who did, book transcription would use like this big hemisphere of glass to magnify, right? But that's not controllable. You can't like put those in series, right? And so the thing to realize is if you make it the right shape, you could put them in series and get a lot of power out of it, right? That's the thing that people didn't get. Or, I mean, again, maybe they did get it and it was lost in history. I wouldn't totally doubt it. I am often a believer that people in ancient times knew a lot more than we think they did. Um, all right. Where were we? Did I check this in? We were trying to do some work today. All right. Great. Have I read any of Graham Hancock's stuff? No, he seems a little bit, he like too much wants to believe in aliens and stuff, right? However, so like I've seen him on Joe Rogan a little bit and I was like, yeah, I'm not buying into what this guy is laying down. But what I do think is that probably civilization is a lot older. Like when they talk about the stuff about like, look, there actually was a huge flood that wiped out a lot of stuff. Like that's plausible to me. I don't think it was like super high technology compared to what we have today, but we don't know. Or let me put it this way. I don't think there's evidence that that was the case. But I don't think there's evidence that it was like, if you imagine what could have existed and then got wiped out in a worldwide calamity, like anything up to like 1700s technology, right? Probably there would be no evidence of it anymore if it was 4,000 years ago, right? 6,000 years ago, 8,000 years ago. I forget what the. No, I guess the usual thesis is this was about 13,000 years ago, right? Right? Wasn't it like 12,000 BC or something? Anyway, like wooden ships 13,000 years ago would not exist anymore, right? So like you don't know that that's not true, right? And we just like the problem is the more conspiracy theory nuts are that are out there that are swearing that the Lemurians did this and that, the more the sane people want to distance themselves from those people by saying, no, that's not true. It's impossible. And it's like, well, like, look, we don't know. There could have been some serious civilization at that time, like serious civilization. We just don't know. And, that's fine. It's fine to not know. Was I able to finish Beyond the Curve or was it too much? I don't know what Beyond the Curve is. What is that? You think they pulled a 4,000-year-old ship off the bottom of the Black Sea a few years ago? That would not be too surprising, right? Because look, we know that ancient Egypt had some serious organizational capacity, right? I mean, I don't know if that ship was Egyptian or someone else's, but like, we know, like, look, whoever built those frickin' pyramids had some stuff going on, right? Of course, if you can build pyramids, you can build ships that are serious, right? Of course. You think it was Minoan? Yeah, ancient Greek, totally. Stolen ships. Yeah. No, I think we would be surprised. So if the Library of Alexandria hadn't been totally burned, we might know a lot more about what people in the past had. it's clear that it's at least a little more than we think, and potentially a lot more than we think, right? Beyond the Curve is a flat earther documentary. Oh yeah, okay, yes, I did watch Beyond the Curve all the way. Sorry, um, I forgot that that's what that was called. It's entertaining. Like I watched the whole thing. It's entertaining. I just feel a little bad because those are all people who are really enthusiastic about a topic, about truth searching, right? And anyone who's trying hard to understand the truth, I definitely have sympathy for, but they just really don't know how to do it, right? So the ending is amazing, isn't it? I don't remember the ending. Wait, what was the ending? I just remember I remember them going to the Air and Space Museum and it's empty, right? Um, I don't remember what happens after that. Oh, right. The thing about where they're doing the experiment, like in the middle of Kansas or something, where it's super flat, and they're trying to like look through look through a board or something at the other board. Yeah. See, those guys, the guys doing that experiment were actually doing the right thing. It's like, look, let's let's actually try to prove or disprove something. Like that's how you do it, right? Most of the other stuff in the movie is not at that level of whatever. But then they explain away the results they don't like. Right. I mean, that's the problem. Now, it is true that experiments are hard to do, right? And so you could have a correct idea and your experiment could appear to disprove your correct idea, but you can't just say that that's happening. You have to like show how it's happening and improve the experiment and all that stuff, like legitimately. Knowing about semiconductors in the 1500s wouldn't really help you make a CPU. Probably not. Although you'd be surprised at what people could do. There's this guy, Sam Zalouf, who you can follow on Twitter, who makes CPUs with rat poison and some other things. It's pretty entertaining. He makes CPUs in his garage with everyday things mostly. Like he had an electron microscope and it broke, so he replaced the tip of it with like a light bulb filament. It's good action. He has pretty high-end equipment. I mean, yes, but you can imagine what he would do if he didn't have access to that equipment. He would be able to do something. He would be able to do something. I don't know what, right? Because I'm not him, but he would be able to do something. You should ask him if he was in ancient Rome, what would he be able to build? He might have something interesting to say about that. All right. I think we're on to the next step. I think that's enough of a distraction. Yeah, we checked in. So his name is Sam Ziloof, Zeloof. I'll tweet his Twitter account. This is his Twitter address. The last thing you would care about would be creating a computer, maybe. I don't know. I mean, maybe you'd be there a month and go like, okay, now I get it. It's kind of boring. Okay, any final on-topic questions? On-topic questions before we move on? What's on topic? Well, things. All right, let's keep going. So we actually, in theory now, mostly have our polymorph progress. This is a little bit weird, but let's move this initialization up to here. Like we can set this initially, right? So progress, polymorph, match progress dot source lambda is source lambda. Okay, so that's all we need there. Now, well, let's just make sure that works. Let's not take anything for granted here. Bam. Bam. Okay, great. Now, remember when we started, for those of you who were here, we did this, and this is sort of our front function that does the setup and then calls these guys by breaking out all these arguments. Let's just pass this state down to these functions now. We'll do that for both of them, and then we'll check in. Right? So I'm just going to, instead of all this stuff, I'm just going to say state. Boom. All right? And again, it was that stuff. And polymorph. Match progress asterisk state, and we'll go here. Bam. We're just pushing the structure through. We're not really changing what it does yet. So we might want to make an alias for inputs. No, let's not do it. Okay, that's good. Source lambda. That's there. Whoops. Okay. Solutions. Okay. Wow, that's an old comment, guys. 2016. 2016. 986. Oh, yeah. Okay, hold on. C++. What am I thinking? You can't just do that in C++. You have to do this. All right. Okay, we forgot that one. All right, that's one of the two functions. It's the smaller one, but it's one of the two functions. Okay. Now, what? Well, we do it for the other thing. That's what. Let's do this part first so that C++ doesn't bite us. All right. All right. Okay. Just doing the same thing we did on the other function. We're doing inputs. We might want to clean this up later. Like I'm not crazy about making things spammy. But honestly, for right now, I just want it to work. Now, you know what? This is not sparking joy. So we're going to do this highly questionable thing. Okay, we had the varargs argument index. Oh wait, this is non-looping. Wait, I put this in the wrong place. We want this here. Okay. Okay. What was our other arguments? I don't. Let's just let the compiler tell us. It's our superpower. Solutions. Wow, is that really it? Okay. Great. We are in good shape unless the tests fail. We are in good shape unless the tests fail. Well, they didn't, so that's good. So let's commit that. So far, what we've done is mostly a cosmetic thing. Mostly, right? But what it allows us to do now is be reentrant into these functions. By using that state. So the way these work is you call this and it tries to do the job it's trying to do. And if it ever decides, oh, I can't actually do this yet, it returns something in this yield upon pointer, which just says, look, here's the thing that's blocking us from continuing, right? And we just want now to start using this state to prevent us from redoing work. And this is where it starts getting a little bit precarious and we might break things. But in the end, it'll be more clear and better. Yeah, the chat is not good right now. Let me just say that. Okay. Okay. So let's do non-looping first. That's a simpler function. So here we're doing, let me just even see where it can fail, right? So, well, I guess it could fail here because we're passing a yield upon. But this is weird because this is weird. All right. So there's really only one place where it could yield, and that's in check that types match. That's an old comment. Um, this is all old. So what's wrong is like why are you asking me to like gossip about somebody else in video games? Like why is that even interesting? Like I'll work on the things that I work on and somebody else can work on the things that they work on. And if you like their stuff, that's great. And if you like my stuff, that's great. And you know, the internet has way too much of talking about things, and I don't really want to encourage that. It's not quality, you know? Actually, you know what? I'm going to say something much stronger about this in a second, as soon as I'm done pouring the tea here. All right. So in the world right now, we have this problem largely caused by the internet where it sure seems like, at least, a larger and larger proportion of people are being consumed by relatively petty things. And when I say consumed, I mean they spend most of their energy on mental energy on relatively petty things. They spend most of their time reading about relatively petty things or typing little messages to each other about relatively petty things. Okay? And so I think it's important that we have a group of people who do not do that. Otherwise, the world is in serious trouble. What does that mean to not do that? Like, what? You want to end up in a place in life where you're doing constructive and useful things that are meaningful and helpful to people, hopefully, right? If you're not interested in that, then fine. But I think most people would be interested in that. And so, how do you get there? Right? Well, you get there in increments, in steps over time, right? And so what matters is at every day in your life, whether you're in a position to take the next step there or not, because it's a series of all these little steps, right? Just like the internet is a series of tubes. It's a series of little steps. And if you're in the mindset to potentially take a next step, then you're ready for it. And then if information comes by that you know how to act on, or if you're ready to learn a new thing and the opportunity to learn that new thing comes up, then you do it and you move forward a little bit, right? If you're spending a lot of time thinking and talking about things that are not conducive to that, then you'll be otherwise occupied. And then when the opportunity for taking the next step comes, you will miss it, all right? Now, this is where I try to figure out how to say this without sounding too harsh, right? The problem is society is almost completely full of bad examples. So what does it look like? Okay, look at people who are old now, who have spent their life doing the most useful and productive and helpful things, right? And just ask yourself, you can look at them as an example and you can ask yourself, what were they doing when they weren't so old that led to this, right? And the answer is probably they weren't gossiping about video game designers. You know what I mean? Like, it's just not that helpful or interesting. It's like, it's a different, like, you know, those old celebrity rags that still kind of barely exist where the paparazzi photographers like follow the movie stars around when the movie stars don't want to get photographed, and like, oh my God, this guy was seen at this location with this person. a lot of what the game industry press talks about now is that kind of thing. They're that kind of publication, and you have to realize that, and you have to realize like, oh, the kinds of things that game industry media are talking about are actually trashy gossip rag things. You have to understand that and realize that it's not good for you in the long term. All right. So that's all. And I don't think it's anybody's fault even that they think about that a lot or ask about that or think that that's the best thing to ask about, because like I said, we're in an environment full of bad examples. And if you just follow the examples, you'll think that that's an important and interesting thing to ask. But the problem is we have to stop following the bad examples, or things are going to things are already going downhill very fast. We have to stop them from going downhill. And the way that you do that is by realizing that the culture around you is kind of insane. And you need to stop participating in the insanity. All right? That's all. That's all I have to say about that. Stop participating in Twitch chat. Mostly, I mean, sometimes Twitch chat is good. It was good, this morning and yesterday and the day before. Twitch chat has weather, kind of like the real weather. So sometimes it's really good. Sometimes it is really not good. Those things have a low barrier to get involved in. Yes, but other things have a low barrier to get involved in too. Like, smoking and giving yourself lung cancer eventually. That's a pretty low barrier to entry. When you're young, like getting involved in like street crime and stuff, that's pretty easy. Doesn't mean you should do it, right? And we don't have the cultural intelligence to realize that these other things are really not good for you, right? What else is easy? Like eating candy all day until you get diabetes. Also very easy, right? That doesn't mean that you should do it. And it doesn't mean we should be accepting of it on a societal level. Have I ever passed a parameter as a reference throughout the compiler code base? I do not like non-const references, if that's what you mean. Const references, fine, right? You can use that to pass a struct. Non-const references I don't like because you have no idea who's going to modify it. So, but it looks at the procedure call site like it's not being modified, but it could be, right? I don't like that at all. I don't do it. Like not even talking throughout the code base, but like I don't do it basically ever. I don't use non-const reference parameters. You can't figure out what check the types match does. That is a very core routine in the compiler where, I mean, say you have a plus and you have a plus b. How do you know if that's a valid operation? That function is what tells you. And then it also does some additional things, right? But that's the function that tells you, oh, a and b can be added together, or no, they can't. The language passes by value is const reference implicitly based on type size. Yes, that's correct. So anything 8 bytes or less gets passed by value. Anything more than 8 bytes is passed as const reference. How do you determine that size? I mean, it's just known at compile time. What do you mean? And it's actually, what I said is not strictly true. Structs always count as big for these purposes. So if you pass a struct, it's always const reference, even if it's like 2 bytes or something. You meant the decision that went into that? It's just the machine register size, right? So like, if your value fits in a machine register and you can pass it by value, then we just do that, right? Because in that case, passing it by reference would actually be slower. Like passing an integer by reference, by const reference to a function is goofy. It's silly. It's a waste, right? So we pass those things by value. But if something is big, we, do the thing. You just think me and Tom Dowd are wrong when it comes to using games to tell a story. I don't know who Tom Dowd is. What is the best book that you've ever read? What's the best novel you've ever read? Straight up question. What are you comparing games to when you say games are good at telling stories? You were told by Tom to write a book if you want to make a story. I agree with that. I agree with that. I mean, maybe not for the same reasons. I don't know what his reasons are behind saying that, but I agree. Do these facilities like the lecture could be exposed for the language in any way? Obviously, it's not a super needed thing. I think if you want a Lexer, it's just a different library, because you want people to be able to do their own version. You want to be able to copy someone's and modify it. So exposing it as an internal compiler thing, I don't think is very helpful. What do I think about C# like parameter passing where you have value types and reference types? I'm not thrilled about it. I think references make things kind of complicated in the type system, and I'd rather not make the type system complicated if I don't have to. But we'll see. We'll see where it goes. Thus spoke Zarathustra. That's not a novel. I mean, if you mean... And actually, that's not even... That's the title of a musical piece, right? The actual philosophy book is actually, if you translate the title, it's just called Zarathustra Speaks or something. But that is also not a fiction. I'm asking just about a fictional novel. It's not a trick question, right? Although apparently it's been retconned so that it's called Thus Spoke Zarathustra in English. I don't know. Maybe I misunderstand it. The title. I mean, yeah, I don't know. I guess you could call it a novel. I mean, yeah, I'm willing to give you that. Like, I don't want to split hairs. Well, I mean, I wouldn't consider that the best storytelling, right? It's like a different thing. But again, if that's your favorite kind of thing, then that's cool, right? You're allowed that. You're not going to believe anyone that says Gravity's Rainbow is their favorite novel. It is my favorite novel. Gravity's Rainbow is a great book. It is my favorite fictional novel. Now you believe me? Well, you believe me just because I said it, but you didn't believe me before? Okay. Anyway, let's go back to... let's go back to actually programming. Oh my God. So we've been just pushing this structural change through, and did I commit it? I think I did. I don't know anymore. Oh, I didn't. Oh, I deleted comments. Okay. Right, we were looking at actually using the state thing. We were looking here, we were saying, okay, that could yield. Right. So what we're going to do is have a cursor. Like we're doing type match checking. I mean, the problem is we have to do this whole thing every time. Because of variable matching. We could do this up here. So what happens is, okay, in addition to checking that the two types match and can be used together in whatever context, whether it's A plus B or passing a parameter to a function or something, right? We do that for all the arguments. And then down here, we say, hey, are there any polymorph variables? Let's copy them. And we can move this copy loop into here. And then once we've done that, we can do this incrementally, right? The reason we can't just automatically do it incrementally is if on the first pass we do a couple things, we get some polymorph matches, but then we stall, then we get down here and we're like, oh, just return blah, 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 right? So, yeah, we're going to change this structurally a little bit and see what happens. The Pulitzer Advisory Board was offended by its content. I mean, I agree that some of it is overwritten and certainly obscene. Yes, I agree with all of that. But that's part of what's great about the book is it's a book with a very high spirit that is, it doesn't care that much about what you think about what it's doing. And I love that. What category does Glass Bead Game fall into? I mean, yeah, I mean, it's borderline. I'm willing to call that a novel. It's been a couple years since I read Glass Bead Game, but I'm willing to call it a novel, yeah. You're trying to print out how to print a vector element in a debugger, and Google assumes you mean C++ vector. Awesome. Awesome. You hate all the novels? Well, that's valid. Okay, let's do this in 2 steps. Let me just do the copy up here. We're going to say we're going to do some stuff here, and we're going to say if poly matching wanted dot matches dot count Okay, so we're just emptying this stuff out into the matches. I'm not sure if this comment is relevant anymore, but we'll see. We're copying stuff into the matches. And then we're resetting. Now that we reset, we have to keep state because we could have the opposite problem where we add some things and then we yield and then we come back and we start from the beginning of the loop and add the same things twice. I believe that will cause problems for us. So actually, what I want to do is I want to say if we had to yield, then we return false. Okay? If we didn't have to yield, let's actually do that. Let's do what we actually had here. We'll break out. Otherwise, we do this stuff. All right? Now, we have to do something up here. So instead of I, we're going to say we're going to make a thing called input input matching input type match cursor. That's a good name. All right. Now we're going to say, instead of a for loop, we're going to say while state input type match cursor is less than state inputs I dot count. Okay. And we do this. We maybe yield we'll move the yield check here. And as soon as we don't yield, we say we do this. Okay. Okay. So we're just renaming it here so that, you know, whatever. So now we need to put this on our state struct, and we're substantially changing what happens. And so this could bite us a little bit. Match, what was it called? Polymorph match part. Here we go. I was like, I don't see it. 64 input type match cursor equals 0. Okay. Maybe I screwed that up real bad. Oh. Ha ha. And this is count. I renamed that a while back and my brain's not used to it. Well, we are now infinite looping. Let's look at our sources of infinite looping. Could be this while loop, or it could be the outer loop calling this over and over. Okay, right here, this check for yield upon, I guess we moved that into the loop, so that's a little scary, but we want to avoid doing the same match again so that we don't add polymorph solutions to the multiple times to the solutions array. All right. So let's just see why it's infinite looping. What's the difference between a novel and not a novel? Do I mean like low quality paperbacks that people turn out? No, I'm just saying like the structure of it, right? So like Zarathustra Speaks is, it's fictional, right? The point of it is kind of to be a philosophy tract, but it's a story. Like you could call it a novel. I wouldn't argue. Like I don't like debates about terminology and debates about where to classify things. It's just, it's a little bit in a gray area. That's all. Glass bead game, same thing. Glass bead game. Glass bead game is sort of I guess it's more like a novel than I even remember. I need to reread it, I think. Because I'm flipping through it, and like my recollection of it is it's more like a future history book that's written in the form of like pretending to be a history book, right? But then I'm looking through here, and there's actually like dialogue and characters talking to each other. So I don't know. I mean, but again, it's in a gray area where it's like the typical novel. No. Would I say it's not a novel? No, because I don't think it's productive to have picky classification arguments. Does the same go for Rand's works? I have not read any Ayn Rand ever. I probably should, just so I'm educated, but I can't say. Yeah, allegory, like that's a way to say it. Anyway, yeah, like, I don't want to get picky about that. So when I first responded thinking, oh, that's not really a novel, that wasn't a good response on my part, honestly. Okay. Let's go. Let's infinite loop. And then I'll make a breakpoint in the place where I know it is happening. Here. Okay, we're inside. That's good news. It means I just screwed up this little loop somehow. I didn't see a continue. Oh, there's a continue right here, guys. Yeah, that's what's looping us. Oh my God, I am so silly. Let's just do this. Well, we'll see. Oh, whoops. We made the debug build and we tried to rerun the release compiler. That is not how you succeed in the game industry. All right, great. We are polymorphin, and in principle, we're doing less redundant work. It's not really enough to see a difference in the output. But this is actually, in principle, at least much cleaner with regard to compiler structure. Now, the place that was making a mess is actually the looping case. This is the non-loop. I mean, there's a loop here, but non-looping means only one pass over the polymorph variables. Whereas, you know, there's a whole multi-pass situation that can happen. So we do that now. And maybe we start by doing this same thing. Let's see. So this is some setup here that copy the new guys onto the old guys. Okay, whatever. So this stuff doesn't yield ever. This is the part that's a problem. So what we can do is up here, we can start putting some state machine on this. So we could say, right? So I made these things before, so I can start doing this again. So this looping work lambda, which we put on here, but we haven't used yet, is going to be for creating this. Because again, if we leave this function and come back later, we don't want to keep copying the source, like we polymorph by copying the lambda and making a new one, modifying it. So like, we don't want to do that multiple times. That's wasteful. So let's start by doing this. If the state doesn't have a looping work lambda, all right, we do this. Okay, so now it'll only happen once. All right. And again, we can yield in here, but if that fails, then we just come back later. All right. So copy the new guys into the old guys. So we can do this. Looping stomped argument types. We do this. We set that to true. Okay. Let's combine this right here. Okay. How is it 8 p.m. already, everybody? I don't know. All right. Next. Looping copied polymorphic input arguments. That's probably this. Yes. Except we need a cursor here. Right? This can't yield. So we're fine. This can yield. So we do sort of have to do something more complex here than what I was thinking when I did this. Or we could just do an intermediate thing where we kind of punt, but I would rather not do that. So I'd rather, so this input, maybe we use this, right? Except it's not actually a type match. Okay, so we're going to say there's going to be a cursor here, just like we did before, but it's going to be called 64 looping. So I'm calling all these looping just to separate them from the non-looping or general stuff, right? Looping input argument copy cursor is 0. And we're going to do the same structure. We're going to go for whatever all right. And we're going to say auto I equals, whoops. All right. So we do the things that we were doing. Now we might need to do something better here. Like if we copy something and the copy succeeds, but the force infer fails, then we need to pick that up. And we need to think about what that means. We only ever want to copy this once. Maybe copy and force infer is not a good abstraction. Maybe we want to copy. We could do a pre-loop where we just copy. That would be cleaner. Okay. For now, we're just going to do this. And then we do this. And you know what? I think we can test this incrementally, honestly. Like we could test this now. It shouldn't be any worse than what we had. There might be some practical matters that I'm forgetting, though. Hey, it worked. Great. What was the issue with the infinite loop? I just missed that there was a continue in there. Like I was manually incrementing the variable at the bottom of the loop and there was a continue in there and like, yeah, it wasn't good. I think about that. So in our new language, we don't have this ability at all. Like there's no while do. I don't like while do that much. But we might want something where you can like increment the thing at the end. I don't know. I don't know, man. Because it is an error. It's a little bit error prone to not have that, for sure. Okay. Actually, wait. I was thinking do while and not while do. Anyway, whatever. What am I doing now? I am... I guess I'm going to propagate this all the way through the loop and then we'll look at the no check-in later. So this is doing iterations. And we go over the inputs. We start variable matching. We do a match. We don't allow ourselves to yield, which is weird. Kind of don't know why that's okay. Maybe we've decided it can't happen for some reason. If it ever tries to yield, it'll assert because we didn't pass a yield pointer, so we will know. So we can yield down here when we copy an argument that is a lambda. This is the thing I think that was causing the pain in the port, right? And then everything else is good. So the problem is so this happens like if you pass a polymorphic function as an argument to something that takes a function, like, you make a quick lambda, pass it to an argument or something, then it needs to instantiate that quick lambda, right? Actually, I'm not sure this is a good assert. I'm not sure that's the only thing, but maybe I'm confused. Okay, so we get a lambda. See, if it's an overload, we actually don't need to copy it. Like, what happens if I just do this? Does it break something? Okay. Not apparently, but I think we're going to try running a debug compiler because we haven't done that in a while. So let's check for asserts. Takes a while to run the debug compiler. Let's start it on the game at the same time. So we'll just get, that's the release, but I do that just to get it in the buffer. And then I go debug. So we're not getting assertions, so that is nice. Oh, I just said that. And then we got one. It's consistent, so we're going to take a look at it. Those were just old breakpoints that we don't want. Okay, so this is something that didn't get handled correctly. I bet it's a complex polymorph case. iprof draw, line 30. This is literally something that I did this week. It's a procedure pointer or value, right, that is assigned to this. Now, I guess what's happening is dummy text width is not ready when this struct gets created or something. Which has nothing to do with what we're working on. So what's really going on is I didn't do a full build with Sokoban since we did this. So honestly, what I might do, we kind of need to fix this. I think since all the tests and stuff check in, I'm going to a little bit put on pause the current thing, which is actually most of the way done as far as I know. We might pick it up later. I also maybe want to eat dinner soon and then come back on the stream for the night. But I had a no check-in here. I'm going to mark that this, and I'm going to check this in, and then I think I'm going to take a break, and maybe during the break I'll attack this problem, which is probably a problem that beta users might encounter, right? So we're just going to have to. It looks like it's probably making the initializer. I don't know. We have to see. So what do we have to do here? We have to do that, and then it's basically both of these copy and force infers. I think in both of these cases, we need to deal. That's all. It's not that hard, I don't think. And then, are there any other yields? Oh, there's one here. Whoops. Whoops. Basically, force infer is really kind of bad, and we would prefer never to do it. And so our job, oh no, there's a fourth one. Our job is to deal with all these force infers. All right. And the problem here is we're going to have to save this matches wanted state because we might like yield in the middle. Like, I don't know, man. We're going to have to take a look at it. But this is promising. We've made good progress so far. Okay, and then that's it. Okay, so we're not doing bad. We just have 4 force infers. We have 5 things to deal with in this function. And then I have this to deal with. But I'm going to take a break and get dinner. And, you know, maybe, I'm not promising we'll do another stream tonight. We may do another stream tonight. Depends on how much I feel like streaming when the time comes. Did I come right with the floating point stuff? I don't know what come right means. If it means we got the performance much higher, then yeah. Like it's roughly competitive with the libc now. It is not faster than the libc, but it's good enough for now. All right, thanks everybody. We may do another stream tonight. See you later.